Hi there. Welcome to Xamarin University. In this short video, I want to show you how the rendering system works in Xamarin.Forms, and more specifically, how you can build your own visual renderers for controls that you create, or to alter existing visual properties or behaviors of the controls that ship with Xamarin.Forms today. If you're not familiar with Xamarin.Forms, it's a cross-platform component that allows you to define your user interface with C# classes, which are then rendered with native controls on iOS, Android, and Windows Phone. It provides a fantastic way to write almost all of your application code once, but still have fully native applications that look and behave naturally on each of your supported platforms. I'm going to be using Xamarin Studio on the Mac. However, you can follow these exact same steps with Visual Studio on Windows. Let me first introduce you to the overall rendering model for Xamarin.Forms. It starts with a control element. The element is the control definition that you work with in your shared code. These all derive from a base class called View and expose properties and events which define how you would like the control to look and behave. These control elements are not tied to any specific platform, but instead provide a platform-agnostic view of the control. When your application executes, the second piece comes into play, and that's the control renderer. The renderer is responsible for taking the control element and turning it into something visual for the platform. On iOS, the renderer would create or render a UI view-based class. On Android, it would be an Android view of some form, and on Windows Phone, that would typically be a framework element or a control type. The renderer code is platform-specific and therefore not shared. In fact, you will find there is a unique renderer for each platform, as you can see here on the slide. Each renderer is tailored to that platform's unique visual characteristics and API. In this example, we define a label in Xamarin.Forms, setting properties like text, text color, and so forth. Then when we run on iOS, the label renderer for that platform creates a UI label to visualize the label. On Windows Phone, the label renderer creates a text block, and on Android, the label renderer will generate a text view. The important thing to recognize is each label renderer is specific to the platform that it's targeting. So there are 3 different classes, each named label renderer, that's responsible for taking our control element and turning it into something visual for that particular platform. You should consider creating a custom renderer in 2 primary scenarios. The first is when you want to build a unique custom control for your application. For example, I might want to create a calendar control or a gauge control. To do that, I'll define 2 things. First, a control element object to generically describe my control and its properties in a platform-agnostic fashion. And second, a custom renderer for each of the operating systems to draw that gauge on iOS, Android, and Windows Phone. The second scenario is if you'd like to customize an existing control to change how it visualizes or to add new capabilities to the control. You really have 2 options with this scenario. First, you can create a custom renderer that replaces the existing renderer provided by Xamarin.Forms itself. In this fashion, your code will now provide the drawing and interaction logic for all controls of that type. For example, you might decide to change the edit control on iOS to draw with square borders instead of the normal rounded edges. To do that, you would register your own renderer on iOS for the edit control, and your code would then get called to create the UI text field, and you could then set up the control however you like. In that example, you would only replace the renderer for iOS, leaving the default one in place for Android and Windows Phone. Second, you could provide all new capabilities for an existing control by creating a new derived control element from the existing one, adding new properties and events to it, and then registering a custom renderer for your new control element, which would then examine the new properties and provide the appropriate logic in response. For example, the platform currently does not support italic text in labels. However, you could easily create a new derived label class and then 3 new renderers, one for iOS, one for Android, and one for Windows Phone, which would expect your custom label and provide italic support using the platform's built-in capabilities. So let's look at an example of this second approach by customizing the built-in box view to support rounded corners. So here I am in Xamarin Studio. I'm going to start by creating a new solution. And I'm going to go down to the mobile app section here in C#, which is where I'll find all of my Xamarin.Forms templates. And I'm just going to go ahead and pick the portable class library version and create a new project here. And we'll just call it Rounded Box View Renderer. Now, because I'm using Xamarin Studio on the Mac, I'm only going to get Android and iOS projects here. If I were in Visual Studio, and if you're running Visual Studio, then you'll get Android, iOS, and Windows Phone. But the principles would be the same regardless. So what I would like to do here is I would like to take the box view element, and I would like to add some new properties to it that we'll then use inside of our custom renderer to actually change the way the box view actually renders on the screen. Now, to go ahead and get started with this, let's go ahead and create a page that just displays a box view. And so I'm going to go to my app.cs here, and I'm going to just delete this content page that's already here, and let's return a new main page. Now, we could just go ahead and create a class here and do this in code, but just for fun, let's actually define our page in XAML. And so I'm going to add a new file and go to the Forms section here and pick Forms Content Page.xaml. We'll call this main page. And so notice I get a XAML file and I get my code behind file. In the XAML file itself, what we're going to do is go ahead and create a stack layout. Let's just go ahead and set the padding to be something. And let's go ahead and set the spacing as well. And then inside this stack layout, let's go ahead and put a box view. We'll go ahead and set a couple of properties. Let's make it red, for example, just so that we can kind of see the box view itself. And I'm going to go ahead and run this, and let's run it in iOS just because I'm already in iOS, and so it's a little easier to run with that, just to make sure that this actually displays properly. So you can see we get our box here, that this is the box view itself. And the common question that comes up is there a way to create rounded corners on this? And today there's not. And in fact, there's a couple of things that box view is not really capable of doing. For example, there's no stroke on this, and so there's no way to actually have a border on this element. And we can't put a shadow on it either. And so there's lots of little things that we could do to kind of customize this. So the first step, as you saw in the slides, is to create a new control element. And so let's go ahead and just add a new file to our shared library here. So this is the portable class library project. This is shared across all of our applications. And so both the iOS and the Android applications share this. And let's go ahead and create a new empty class. I'm going to call this class Rounded Box View. And I'm going to go ahead and drive it from box view. Now that of course comes from Xamarin.Forms, and so I'm going to go ahead and add in my namespace. And then let's add some properties. Now we could actually add in properties just using the regular property syntax. So for example, I'd like to add in a corner radius. Well, we could just do this. And this will work. All right, this is a perfectly acceptable way to add properties into your element. However, there are certain key things that are in the Xamarin.Forms framework that you're immediately not allowed to use if you use this style of properties. And specifically, data binding is not going to be available for this property type. In order to take advantage of data binding in Xamarin.Forms, your properties need to be bindable properties. And that means that you need to be deriving from bindable object, which it turns out BoxView does. BoxView derives from view, which in turn derives from bindable object somewhere back in the hierarchy. And once we derive from bindable object, we can then start creating bindable properties. And so let me just show you what that looks like. I'm going to type one out just so you can see the full syntax, and then we'll create some more just using a nice little code snippet that I have. But the way we define a bindable property is there are two pieces to it. You first create a read-only static field of type bindable property. And we'll just call this one corner radius property. And I'm going to go ahead and assign this to bindable property dot create, and then this is actually a generic method that takes the type that owns this property. That's going to be my rounded box view, so that's the owner for this property where it's being defined, and then the type of the property itself. I want this to be a double. And so once I've defined that, then I have a couple of things that I can provide here. So notice these are mostly link expressions. That really the only thing that you absolutely have to provide is a getter for this. And so that's going to be something that retrieves the value itself. And so we'll just say p goes to p, I wanted a p there, p goes to p dot, And so notice that we don't have any properties here that match corner radius. And that's because we actually need to define one. So I'm going to go ahead and just type in corner radius here, recognizing that I'm about to define that particular property. And then the second thing that we need to give it is a default value. And so I'm just going to go ahead and set the default value to 0 for this particular property, and we'll go ahead and close this off with a semicolon. Then the second thing we need for a bindable property is an instance property wrapper that goes and retrieves the value from this. And this again is going to generally be public. It'll be a double, and we're going to call it corner radius. And this will of course have both a getter and a setter. And the getter, what it's going to do is return with a cast base.getValue, passing in that bindable property, corner radius property. Okay? The setter, in the same way, is actually going to call base set value, passing in that property, corner radius property, and the new value that we'd actually like to set on this particular property. Now, notice that we're not actually storing the value ourselves. Instead, we're deferring to some base class method. These methods actually come out of the bindable object base class. And so the value is actually going to be stored by that base class itself. And you can kind of think of it as a dictionary where the key is the property here, the actual bindable property that we've defined, and then the value is whatever value is actually being set in that dictionary. And at runtime, the system will then call this getValue method to go retrieve any of these properties. This nice little instance wrapper here is really for convenience. We can use it, it's fully type safe, so notice it automatically casts our value to a double. It ensures that when we set this, we're always setting a double so that it's not a normal object value. And so it's used for convenience purposes, but the reality is the underlying system is actually going to use this getValue and setValue method. And we're going to want to define all of our properties on any control element that we create this way. And so this is what's going to enable data binding to these properties. And so let's just go ahead and create a few more. As I mentioned, I actually have a nice little code snippet here to actually generate these. And so for example, perhaps what we'd like to go ahead and create is a stroke property. This of course is going to be a rounded box view, and my value for this will be a color. And so my default color here, rather than using default color, let's actually use color.transparent. And so we'll say the default color for our stroke will be a transparent color. And then notice it's exactly the same way. We have two pieces. We have the static field defining the property value, how to get to it, and what its default value is. And then we have an instance wrapper to go retrieve the actual value set on the object itself. Let's go ahead and set up another one. This one will be stroke thickness. And so this will just define how big it is. So rounded box view, this will also be a double. And we can use default double here. That'll just generate a 0. That's fine. Okay, so this now defines my control element. So this is my representation of this control from the Xamarin.Forms perspective. And let's go ahead and add it into our XAML page now. So I'm going to go over here to my XAML, and instead of using box view, I want to use that rounded box view. And so I'm going to replace this with rounded box view. And notice it doesn't seem to matter to XAML itself, but this actually will not compile, or rather it won't run because it doesn't know about this class. It knows about all the default built-in Xamarin.Forms classes, but this is not one of them. And so in order to use this custom class, I actually have to define an XML namespace for this. And so we're going to say XML namespace me, and this is defined just exactly like you do in WPF or Silverlight. We say CLR namespace. We tell it what namespace that is. This is RBV renderer, semicolon, assembly is equal to RBV renderer. Now, unlike WPF or Silverlight, we actually have to supply the assembly here, even if it's locally defined in our assembly. So this is a required piece to the CLR namespace tag. You have to supply both the namespace of where the control lives, in other words, this right here, as well as what assembly is it in. And this is the simple name of the assembly. So you wouldn't include DLL or EXE or anything like that. It's the name, which might include the public key token and the culture and the version and that sort of thing if you want to be very explicit about it. So once I've defined that namespace, I'm then going to come and actually say this rounded box view is actually in that namespace. And so now we've got me rounded box view. Let's go ahead and run this and see what happens. So notice that I get my box view again, except it's not rounded, obviously, because the system doesn't have a renderer that's defined for my rounded box view. However, it recognized that my rounded box view was deriving from a control that it did know about, the box view, and therefore it used the renderer for the box view in order to actually display that information. So let's add that second piece in. So remember from the slides, there were two pieces to any control we use. One is the element, that's what we've created here, and then the second is the render. Before we add that custom render, let's do one step. Let's go ahead and update our packages just to make sure we're on the latest version of Xamarin.Forms. And in particular, I want to get the new version of the rendering subsystem. Currently, that is, if you right-click on this, you can see it's currently 1.1.6206. Yours may be slightly newer depending on when you're actually trying to perform these steps. Now let's go ahead and add our new file. We'll call this rounded box view renderer. And what I'm going to do is I'm going to derive this from the existing renderer that's built into the framework to draw the box view itself. And that's box render. And if we kind of navigate into this, you can see that this actually derives from a class called Visual Element Renderer of type box view. And if you navigate into this, you'll actually see that this is actually a UI view. And so really what we're creating here is a UI view because this is iOS and that's how we draw things in iOS. Visual representations of things on the screen are drawn or rendered with this UI view class. And so what we're going to do is we're going to go ahead and replace the existing implementation for box render to render a new box view that actually has rounded corners. And so let's go ahead and override the draw method first. Now this is the draw method coming from UI view itself. So this is not really part of Xamarin.Forms. This is actually the drawing mechanics that are just part of iOS. And the first thing that I want here is I actually want the element that's describing my data. In other words, that rounded box view class that is actually passed into this. The way that I get to that is there's a property here called element. Now you can see right now that's actually a box view. That's because we're deriving from box render and therefore the T that got passed into view render was a box view. And so we're going to have to go ahead and cast that. So we'll say this is rounded box view is equal to rounded box view this element. Okay, that will give me access to all of my data that represents the actual information that I would like to use to customize this particular rendering. Then let's go ahead and set up our actual rendering. So let's go get a context. We'll put that into a disposable block. Let's go ahead and set the fill color for that. I'm going to go ahead and grab the color off of my rounded box view. What set fill color wants is a core graphics or CG color. The color that we've got defined here is actually a Xamarin.Forms color, and they're not compatible. So what Xamarin.Forms does is in each one of the platform-specific modules, and so that is, if you go look at your references here from your packages, you'll find that there's always a platform DLL. In this case, it's Xamarin.Forms Platform iOS. Inside of those platform DLLs, there are extension methods that kind of convert our platform agnostic classes like this color class into a platform specific class. And so you'll find here that there is actually a 2CG color that we can use in order to automatically convert from our Xamarin.Forms class into something that's more appropriate for iOS in this case. And so we'll set our fill color. Let's set the stroke color. That's going to be my stroke. And in this case, it also wants a CG color. And so we'll go ahead and do that. Let's set the line width for this. That's going to be my stroke thickness, which we misspelled, and so we'll want to fix that. Let me go ahead and jump to stroke thickness over here in rounded box view. So I'm just going to use the refactoring to go ahead and rename that. Let's do the same thing here. So stroke thickness and stroke thickness property, perfect. Come back here. Now it's stroke thickness, but notice that what this wants, if we look at it, is a float, but what we're passing in is a double. So we just need to do a nice little cast here, and that'll let that compile. So now we've set that up. Now let's go ahead and inset by our stroke thickness. This comes from a extension method coming out of Monotouch Core Graphics. Once I have that, we can then define our radius. Now, what I'm going to want to do with this radius is I'm going to want to constrain it because the way we're going to draw this here is by actually drawing a path. And it turns out that if you make the corner radius too sharp, that iOS will throw an exception. So we want to make sure to put some minimum maximum ranges on this. And so let's just do that just through a little expression here. So we'll just say we want it to be the minimum of radius from our height divided by 2 and our width divided by 2. That'll actually set it up so that it'll be correct and it won't exceed the boundaries that iOS expects. Then let's go ahead and create the path. So we'll use the new CG path from rounded rect. pass in our actual bounds that's inset, pass in our radius. That'll create me a nice little path. We can then add the path to our context. And then let's go ahead and draw it. And I want to go ahead and both fill it and stroke it. Now with this in place, this will now draw my box view, and I'll get rounded corners assuming I've set some of those properties. And so let's do that. Let's go ahead and change our main page XAML here. And let's go ahead and set our stroke to be yellow. And let's set our stroke thickness to be 2. And let's set our corner radius to be 20. All right, so now we're using some of these new properties. Now I'm going to go ahead and put a breakpoint here because you're going to see something interesting, or rather something that maybe isn't that interesting. Let's go ahead and run it. And notice that we didn't hit our breakpoint and we still have a square box view here. So it completely ignored my new properties, and worse, my visual render didn't get called. The reason it didn't get called is because we actually have a third step, and that is we need to associate this element that we created, rounded box view, with this renderer that we created to render it. The way we do that is through an assembly level attribute. And so we're just going to use assembly, and we'll say export renderer, and we pass in the actual type of the element, and so that's going to be rounded box view, and we pass in the type of the renderer, rounded box view renderer. So we need using statements for both of those, and there we go. Now with this in place, put our breakpoint here, let's run it, and now you'll see that we actually hit our breakpoint. And so notice we're coming from iOS here, and so this is actually being called in response to the system trying to render one of those rounded box views. Let me go ahead and remove my breakpoint and just go ahead and run. And now you can see I get a nice rounded shape on my box view with my 2 pixel stroked edge that's in yellow. Now I can use this exact same approach when I'm actually dealing with Android as well. And so Android is no different. Let's go switch over to our Android project. I'm going to set this as startup, and let's just add in a new file here. Call this the same thing, rounded box view renderer. And I'm just going to go ahead and steal my export, since we're going to use the same one. It was a deliberate mistake, just to show you how it works, but we'll put it in here and just add in all of our namespaces. Now notice that in this particular case, we're sitting actually in this RBV render Android, and I'm going to do the same thing. We're just going to go ahead and derive this from box renderer. That comes out as Xamarin.Forms platform Android, and if we go look at this one, you can see that it derives from that same visual element renderer, but if we go into this, you'll see that this is actually a view group, which ultimately is an Android view. And so this is now deriving from iJava, or implementing rather iJava object and deriving from the Android view architecture. All right, so let's do the same implementation here. What would it take to actually create this? Well, the first thing we need to do is we'll need to override that draw method, just like we did before. But notice this one actually hands us a canvas. And so we actually get a canvas object here. I'm going to go ahead and get rid of the draw. And I'm going to need a constructor here because I need to go ahead and call set will not draw false. By default, the view hierarchy in Android will automatically turn off calls to draw because it assumes that you're kind of setting it up a little bit differently. In this case, I want to go ahead and tell it we need the draw call because that's actually where my rendering is going to be done. So let's go ahead and get that same rounded box view. Remember, that just comes from my element property, so these are very consistent, so the models are the same across all 3 platforms. The difference is in how we render, not how we get the information itself. Let's go ahead and get our drawing rectangle. And then let's go ahead and inset it by our stroke thickness, and so I'm going to create a new one called interior. We'll just use that inset, and again, I'm going to take my rounded box view, stroke thickness, and that will inset my rectangle. Then let's go ahead and create a new paint object. I want to set the color for this paint object to be my color that I want to draw with. Now, in this case, again, this is a Xamarin.Forms color, but what we want here is an Android color, and so there is, on this platform, a toAndroid extension method that we can use. Let's go ahead and turn on anti-aliasing as well. And then let's go ahead and draw in our filled shape. And so we'll take that canvas, let's just draw a rounded rect, pass in our new rectangle for the interior. So we want to draw the interior first, and then we'll go ahead and use our corner radius. These need to be cast to floats because that's what it wants here. So we'll say corner radius, and then we need to pass in our paint. And so there's our rounded rect draw. And then let's go ahead and change the paint and then draw the outline. And so we'll say color is now going to be stroke toAndroid. Let's go ahead and set the stroke width. So that's a float that we'll need to cast from our stroke thickness. And let's go ahead and set the style for this to go ahead and stroke. And let's go ahead and draw our final round rect. In fact, let me just copy this one. We'll paste it here. Except this time we want to use the full rectangle, not the interior one, but we'll use the same corner radius and the same paint object. Let's give this one a shot. I've started my Genymotion emulator. We'll go ahead and let this run. And now you can see that I get my same rounded rectangle here on Android. Now, there's a couple other minor things I want to show you real quickly. So let me go back into the XAML here, and let's add a couple of little things into the XAML. So in particular, what I would like to see is, what if I start changing that corner radius? And so let's put in here a slider. And in fact, let me put a label first. And so we'll say the text is going to be corner radius. And then I'm going to add in a slider. And I'm going to give this a name. We'll call this the slider. It doesn't really matter. But let's go ahead and set the minimum to be 0. And the maximum for this to be, say, 200. It's the same size as the rounded box view. Now, what I would like to do is I would like to set it up so that as I slide the slider, we change that corner radius. Now, we could do that in code, but because we used bindable properties, we can now use a binding to connect these together. And so here's how it works. The first thing we need to do is we need to set a binding context. So every object has a binding context, which is where its bindings are getting their data from. Now, that's actually going to be my rounded box view. And so I need to put a name on this rounded box view. I'm just going to call it RBV here. And what we'll use here is a markup extension called reference, and we give it the name, RBV. And so xreference RBV says that this rounded box view is now the source of data for any bindings that I use on the slider. Now, one important note to make here is that if you use this xreference here, the thing that you're actually referencing has to be defined before the reference. In other words, we don't allow for forward references today in XAML. That may change, but for now, you need to make sure that if you reference an object, you need to make sure that object is defined prior to the reference. And so we're going to set our binding context, and then I'm going to take that value and I'm going to apply a binding here. And I'm going to say the binding that I want to use is corner radius. I want to bind to the corner radius property. And the mode I'm going to use here is one way to source. Now let me explain what I'm doing here. The problem is that rounded box view, we could actually define this binding on the rounded box view. So I can move the slider above the rounded box view, create my binding, and then set the binding on the corner radius property right here. And if I did that, what I would have to do is set my binding context for the rounded box view to be the slider, and then my binding would be retrieving the value from the slider. The problem is if I want to have multiple bindings on this rounded box view, I can't do that if it's different objects because I only have one binding context. The way we get around that is you set this mode. Mode can be one of 3 different values. It could be one way, 2-way, or this weird one way to source. And what it says is I want to take the value property here on the slider, in other words, what's the current position of the slider, and I want to push it into the corner radius. And this is how you get around the issue of only having one binding context. You assign the binding context to the thing that's changing the value, and you just use this one way to source mode on the binding to push those values into the object itself. And so now with this in place, as we slide the slider, we should see the rounded box view change. I'm going to go back to my iOS version here and set that as my startup. All right, let's go ahead and give this a shot and see what happens. And so now we should see a slider underneath this with the corner radius, but as I slide it, notice that my corner radius isn't actually changing. In fact, it's staying at 0 because that was the initial value of the slider. Now, my problem is the value is actually changing, and it is actually pushing that change into the control element itself. The issue is that the renderer doesn't realize that, and so therefore it's not actually re-rendering anything. The way that we fix that is we have to override another method here called onElementPropertyChanged. This is called to tell you that properties are changing on the element itself, and therefore it gives us an opportunity to do something in response. And so what we want to do here is we just want to look at the inbound property name. So if the property name is equal to roundedboxView dot corner radius property dot property name. If that's the property, then we want to redraw our element. And in fact, we want to do that in a couple of cases. So let me just copy this line. And let's go ahead and say if the property name is equal to stroke property, or if the property name is equal to stroke thickness property. In all of these cases, we want it to re-render that particular shape. And so we just do it exactly the way we would do it in any iOS type application. We set sets needs display, and that'll cause it to re-render. I also want to go ahead and pass this down to my base class on element property changed, passing the sender and the event args, because this will invalidate other things from the base box view properties as well. Once we've got this in place, let's run it again. And now you can see, as I slide the slider, you can see that it changes. Okay, so now I'm seeing kind of dynamic effect of that corner radius. Now there's one more thing I want to show you. I'm going to rename this to box render v1. What if I were building a custom control where I didn't have a base renderer to work with? In that case, what I'm going to want to do is create my own renderer using the built-in view renderer technology that the box renderer is currently deriving from. So let me show you how that works. I'm going to create another one, except I'm going to derive this one from that view renderer base class. And so what this takes is two parameters. The first is the control element that we're using. That's rounded box view. The second is the type of view that we're going to create in response. We're just going to go ahead and use the base UI view class here. Now, with this in place, I can now actually do this in a different way. So before we were kind of drawing it manually, but say for instance that I'd like to add in some other pieces here. So maybe I come back to my rounded box view and we add one more property in here. Let's add in a has shadow property. We'll make this a Boolean, and we'll go ahead and set the default to false. And let's go back to our app.cs, or rather our main page.xaml.cs, and let's put in here another label. We'll set the text to be has shadow. And then let's go ahead and put in here a switch. And let's go ahead and set the binding context for this to be that same object, xReference, RBV. So now we're going to use two different objects to drive similar things. And we'll go ahead and say is toggled is equal to binding has shadow, mode equal one way to source. And so that'll go ahead and create a nice little switch that will toggle the has shadow property on our rounded box view. And so that brings us back to our rounded box view renderer. In iOS, another way to create the kind of visuals that we're using here is to actually use layers. And so we can use multiple views together in order to actually create the same type of visual that we were drawing with the low-level primitives using the UI graphics context. And so let's use that approach, and that's why we're no longer going to derive from box renderer, but instead we're going to actually just derive directly from view renderer and then provide our own native view to represent the visualization that we're going to create here. Let's go ahead and override the onElementChanged method. This gets called when the rounded box view is being associated to this renderer. So when the renderer is being decided and the system picks this renderer for that rounded box view element, it will then assign the element to this rounded box view renderer so that we know what we're rendering. We'll go ahead and pass that down to the base class, that's fine. And then we can go ahead and pick up our rounded box view from e.newElement. So this will be the actual element being assigned here. And we can say if RBV is not equal to null, then we want to go ahead and kind of create a UI view graph here. And so the first thing I'm going to do, since we want to support a shadow, is I'm going to create a new shadow view, which is just a UI view. Then I'm going to go ahead and create a child view. So anybody who's ever tried to do shadows in iOS, you'll quickly find that in order to do rounded corners, you need to go ahead and clip your content, but then that clips your shadow. So in order to get a shadow properly on a rounded corner object, you have to actually have two UI views working in tandem. So the outer view is not clipped and it provides the shadow, and then the inner view, which will be just another UI view here, and this will be my child view. So I'm going to just create a new UI view. This is where we're going to actually supply the background color, and so that'll be rbv.color.toUI this time. So this is actually a UI kit color. We'll also set some layer properties here, and so I want to go ahead and set the corner radius on the layer. This is a float, so we'll set corner radius. We want to set the border color. That's going to be our RBV stroke. Now this actually is a core graphics color. We also want to set the border width, That's going to be a stroke thickness. And I want to say masks to bounds. And I'm going to set that to true. Now this actually needs to be cast to a float, because that's actually a float value. Let's go ahead and set the auto resizing mask so this child view will automatically resize with its parent. Put our semicolon there. Let's go ahead and add it to our shadow view. And then we can say if has a shadow, then let's go ahead and set up the shadow view. So we'll set the shadow color. So that'll be a black. The shadow offset. Shadow opacity, we'll set that to 1. And the shadow radius. And the last thing we need to do is go ahead and assign our UI view, which is the shadow view here, to this object. And so there's a method for this called setNativeControl. We pass in this native control type here. UI view is what we're using in this particular case, but maybe if I were creating a text field or a button, I would pass something different. This will then assign the native control for the renderer itself. Now we're still going to want to manage our property change notifications here, because when we change property values on that element object, I want to make sure to adjust all my layer properties and my UI view properties here. So let's just copy that property change notification. Let's paste it in here. I'm not going to want to redraw things. However, I do want to look at each one of these property names. And so let's go ahead and separate out these if conditions, because I want to look at each one independently. And then we'll do something in response. So if the corner radius has changed, then I'm going to want to go to that child view and pick up the corner radius off of its layer and actually adjust that. So we'll say child view, layer, corner radius is equal to float. And now I can actually go to my element property here, and notice now my element property is a rounded box view. That's because we're now deriving from view renderer and we're passing in rounded box view as our type. And so it understands that that is my element type here. And so let's take that element and let's go pick up the corner radius, and we'll set that if the corner radius changes. If the stroke property changes, then we'll want to go to the layer and we'll take the border color and we'll go ahead and set that to element stroke CG color. If the stroke thickness changes, then we'll want to do the same thing but to our border width. Now, because we're now using layers and our own UI view in order to draw this, I'm also going to have to manage the base class property. So passing off to the base really isn't going to do a whole lot for me because we don't have anything that's drawing those colors. And so we're also going to have to test for the property name of box view color. And then when we see that change, let's go ahead and change our background color to match what our new color property is. Now this again is a UI color this time, so we'll go ahead and adjust that. And then last but not least, let's watch our property name rounded box view has shadow property. And when that changes, we're going to want to go ahead and look at the shadow and decide to go ahead and set a shadow or not. And so we'll say if element has shadow, then we want to do one thing, else we want to do another thing. And let's just copy our code from right here, and we'll paste that in. And here's a cool trick. So here we were using shadow view. What I want to use now is I want to use the native view property. So just like we have an element property, I also have a native view property, and this currently is set to a UI view. And again, it's because we passed in UI view as the native view type. And so what we're getting back here is whatever we set on this native control. And so I can go to that native control, and that will give me the shadow view. If you hold down your Alt key or Option key on the Mac, you can actually do a block select here, and then when you type over this, you'll actually be able to get that native view. And so I'm just going to go ahead and copy this, paste it in here, and let's set this to be clear CG color. Let's set our size to just be regular size. Let's set the opacity to 0 and the shadow radius to 0. And that then will allow me to handle the property change. So as each one of these property changes, I'm going to adjust my view properties. Let's just make sure it all works. Let's go ahead and run it. And so you can see that as I change my corner radius, it's changing this. When I flip my shadow, I get a new shadow on top of it, and the shadow matches my corner radius. If I turn the shadow off, the shadow goes away because we're removing that layer. And so you can see it all seems to be working exactly the way we want it to. To recap what we've done, to utilize a custom renderer, you create the control element object either from scratch or by deriving from the View base class, or deriving from an existing control in the Xamarin.Forms framework. Remember, this is shared code, so it would be placed into a portable class library or a shared project. Also, remember that we want to use bindable properties to expose features so that we can use data binding to connect things together. Next, we create a View renderer for each platform we want to target. Again, we can either derive from an existing renderer and just override its behavior, or you can derive from View renderer, tview, tnative to supply a custom rendering based on a native control, where tview would be your control element and tnative would be the actual native control for that platform. Keep in mind that the control can be anything you like, even base controls like UI View in the iOS platform. Finally, we add an export renderer attribute at the assembly level to associate the control element defined in our shared code with the renderer on the platform itself. When Xamarin.Forms initializes, it scans all the loaded assemblies and finds all the export attributes and creates an internal mapping of Xamarin.Forms controls to native renderings. One important note to make about this initialization is that it will only look in assemblies that are currently loaded into memory. That means if you're trying to create shareable component libraries that you're going to share across different applications, you will need to make sure to call something in that library prior to calling the forms init method, so that the assembly gets loaded into memory. Just adding it to the project will not be sufficient to load the assembly. You have to use a type directly in your code to get it loaded prior to calling forms init. I hope you've enjoyed this short webinar on customizing renderers for controls in Xamarin.Forms. This is just a short example of the type of content that you'll find in Xamarin University. When you enroll, you'll get access to a whole suite of advanced sessions about Xamarin technologies, which are available in both live and recorded form. You can register for one-on-one sessions with instructors to talk about architecture and your specific development goals, and you have the opportunity to take the certification exam and become a Xamarin certified mobile developer. To get more information or to enroll in Xamarin University, visit the link on the slide. Thanks for watching, and we hope to see you in a class soon.